Hi guys, welcome back. This is Wednesday's homework. It's, as usual, 8 questions. If you are using this as a time trial, you want to set a 15-minute timer and sit yourself down in a quiet space to use this as a practice test. If you're still at a place where you're kind of studying and learning the skills for the first time, take your time, work with someone else, and then come here to check your answers and hear the actual explanation. Question number 1's on the screen. Great, so question 1, the first thing I notice is that I am looking at end behavior, which means that I can use the shortcut. The shortcut is to look at the highest degree on the top and the bottom. In order to know what it is, however, I have to imagine foiling everything out. It doesn't mean I actually have to FOIL it out though. If you think about it, when I multiply all 4 combinations of terms on the top, the highest degree term is going to come from multiplying x squared times 3x squared, and the term is going to be 3x to the 4th. Similarly, on the bottom, the highest degree term is going to be negative x cubed times x, which is negative x to the 4th. Looking at these two, since they have the same degree, the answer to the limit is going to be the number that is the ratio of the coefficients. So it's going to be 3 over negative 1, which is why the answer was negative 3. The instructions for number 2 say find the derivative, and the function is an outside and an inside, so I'm going to use chain rule. The outside function is ln of something, and the inside function is 5x cubed plus 5x squared. And their derivatives are 1 over something and 5x squared plus 10x respectively. Now we put it all back together, starting with the derivative of the outside, plug in the inside, multiply the derivative of the inside. And I can rewrite this just as a single fraction. And in fact, that can be simplified. Now, I might at this step take a brief glance over here to check out my options, because sometimes maybe that'll just be it. But looking at the options, since that fraction isn't here, I'm going to need to simplify. The first thing I notice is I can take out a GCF on the top and the bottom, and that GCF actually allows me to cancel the coefficients of 5 and 1x. So I'm left with x squared over x times x plus 1, and that is the same thing as answer choice D, which makes that the answer. Question number 3. So this question is really just testing whether you know what a vertical asymptote means. And I strongly recommend, most people in our class are visual thinkers, so I really recommend that you sketch a picture of what you're talking about, and then your process should be to compare each statement to your sketch and ask yourself the question, is this true? Does this have to be true? For example, here's a set of axes. If the function has a vertical asymptote at x equals 2, we would expect there to be like a dotted line, or maybe we don't see the dotted line, but an invisible vertical line at 2. And the function is going to get really close to this line, but not necessarily touch. For example, we could consider like the reciprocal function. Obviously, there are a lot of other functions that would have vertical asymptotes. They could both be going up or both be going down. But now let's look at this. Statement 1 says f of 2 doesn't exist. That means if we plug in 2, we don't get an answer. Well, that's true. By definition, if the green line is the function and 2 is a vertical asymptote, then the function can't cross that line. It goes close but never actually touches. That's right. The limit as x approaches 2 of f of x equals infinity. Well, the setup is right. This is very close to the definition of a vertical asymptote. But thinking really critically for a second, we're getting close to 2, and we can get close to 2 from the right side or from the left. The y values in this statement are going to positive infinity. Is that true for this graph? Well, if I come from the right, it's true. But if I come from the left, the y values as I get close to 2, the y values are going to negative infinity, not positive infinity. So this statement could be true, but it doesn't have to be true. And the question is saying which one must be true. Here I have a perfectly good graph with the vertical asymptote at 2. And for this graph, this limit doesn't exist. It doesn't equal positive infinity. It doesn't equal negative infinity. The limit itself doesn't exist because different things are happening on each side. Now, if both of these curves were curved up, then 2 would be true, which is a possibility. But also, both of these could be curving down, and it would still have a vertical asymptote, but this would just be totally false. It would be negative infinity, the answer to the limit. For number 3, it's saying the limit as we approach 2 from the positive side has to equal the limit as we approach 2 from the negative side. Well, that's kind of a variation on the last one. Clearly, we have an example here where the sided limits don't equal each other, but it does have a vertical asymptote. So that doesn't have to be true either, which is why the answer was A only. Number 4. As usual, I start with understanding the directions. Evaluate this means I should take the derivative and then plug in -1. And then looking at what information I'm given. I'm given information about a function f, and I'm given actually what its y value is and what its slope or derivative is when x equals -1. And there is actually a slight typo here. If you would change f prime of -1, that should be f prime of +1 in order for this question to work out. So I have some information about f, and then g of x is defined using this expression. I don't exactly know how it's all going to work together, but I'm going to work with what I understand, which is that g of x is a function, and I'm going to take its derivative. In fact, the first thing I notice about g of x is that this is a product of 2 other expressions. So I'm going to use the product rule to take the derivative. And this turns out to be pretty easy for the first function. U and du are easy to find. And actually, for v, I might as well just write f inverse of x. I don't really know what it is, but I understand that that's some function. It's the inverse function. And what's difficult is just the derivative. And the best thing is just to not overthink it. We want to know what the derivative of this function is. So I'm just going to go ahead and write f inverse prime of x. Again, knowing full well that we're not really sure what that means. So I've taken the derivative. It's possible there's some way to simplify, but I don't see anything I can do right now. Notice that f inverse and f inverse prime, these are 2 different functions, so they're not like terms. Also not like terms because x squared and 2x are totally different. So I'm going to go ahead and plug in -1, at which point I end up with an expression that looks like this. Now, -1 squared is +1. And I'm trying to multiply that times the derivative of f inverse of -1. We are not sure what that means. I don't know. I'm going to leave it blank for a second. F inverse of -1. This one's a little bit easier to process. Basically, this is saying -1 is the input, and we want to know what the output is. And this is what you have to think about what inverses are. If you go back to the original problem, they tell us that f of 1 is -1. In other words, we know that the point 1, -1 is a point on the original function f of x. Well, think about what it means to be an inverse. An inverse is a function that has all the points that have opposite x's and y's. In other words, since -1, 1 comma -1 is on the original function, then the point -1, 1 with the switched x and y has to be a point on the inverse function. And the thing that I'm asked to evaluate right here is what is the y value that the inverse function gives me if I input -1. Well, look at this point. This point has an input of -1, so the output or the y value is just a regular old 1. The answer to f inverse of -1 is 1. That's what it equals. Similarly, 2 times -1 is just times -2, and I'm 3/4 of the way there. I've got my first and last 2 numbers. I still need to figure out this number. Think about what this means. The derivative of f inverse at -1 means the slope of the inverse function at x equals -1. Again, think back to what you know about inverses. We consider these to be corresponding points. They're points that kind of line up if you imagine flipping your inverse function over that diagonal line. And we did a little experiment earlier in the year to determine a really neat property of the tangent line here and the tangent line here. And that property was that the slope of these 2 points are reciprocals of each other. And that's what it means to be an inverse function. The corresponding point, the point that has the flipped x and y, has a similar derivative to the original function. It's actually the reciprocal of the derivative of the original. So the derivative of f inverse at -1 is going to be the reciprocal of the derivative of the normal function at +1. And again, that's not because -1 and +1 are opposites. That's because -1 is the x value and 1 is the y value on the inverse function. And then if you flip them, this point has the opposite x and y. So the derivative of this point, the slope of the function at this point, is 2, which means that the slope of the inverse function at this point has to be 1/2. Rewind right now and listen to that explanation again if it doesn't make sense to you. Try Googling inverse functions or finding your notes. Work your way through this concept. It's one of the hardest questions on this practice test. The rest is easy. 1 times 1/2 is 1/2. And 1/2 minus 2 is -3/2. And that's just a fraction thing at the end. The correct answer being B. For question 5, notice a couple things right off the bat. Line normal to. Normal is perpendicular to the tangent, right? And we can only talk about a tangent line when you're talking about at a certain point. So we've got the x value of that point. And basically our answer is going to be in point slope form, and then we're going to have to fill in whatever information we don't have. For these questions, I like to work my way backwards. And I already know what the actual x value is going to be. That's given to me. It's pi/4. So I'm expecting something that looks like this. And I'm going to need to figure out the slope and figure out the y value. They're actually 2 totally separate steps. You can do it in any order you like. To find y, I'm just going to take the x value and plug it into the function, which looks like this for your first couple steps. And I switched it to cosine because my next step is going to be to use the unit circle, and cosine's easier to do than doing secant directly. Next, when I look at the unit circle, 3 pi/4 means take half a circle, which is pi, divide it into 4 equal parts, and move 3 of them around the circle. So it's going to be this point right here. And you should have memorized what the coordinates of that point in pre-cal. The x value is -√2/2, the y value is √2/2, and cosine corresponds to the x value. So 1 over cosine of 3/4 is really 1 over -√2/2, which actually just equals -√2. If you're confused about the middle step here, I did keep, change, flip, and simplified the fraction. And then actually, the square root of 2 is the number that if you multiply by itself gives you 2. So 2 divided by the square root of 2 is another square root of 2. You could also rationalize this fraction by multiplying √2 on the top and the bottom. You would get 2√2/2, and the 2's would cancel. Same thing. Enough said. That's what it equals. There's my y value. So if I imagine plugging -√2 back into my answer, this negative and the negative from the y value cancel out, and it's going to be plus √2. If I'm keeping track of my answer choices here, I've now narrowed it down to B or C, or I guess technically E, if these slopes don't turn out to be correct. Next, we go back to find the slope, which means I'm going to take the derivative, and then I'm going to plug in the same x value, and then I'm not going to forget that I have to take the reciprocal, because the slope's actually normal to what we find when we find the tangent line. The slope, the derivative that I get, is right here, and it's just a chain rule. That's where that 3 comes from. You only multiply it once because it is the interior. And then from there, I plug in the x value, which looks like this. Now remember, we've already taken secant of 3 pi/4. We did that work right here, and we used the unit circle. So I know that secant of 3 pi/4 is -√2. And tangent of 3 pi/4 you can evaluate by dividing y by x on the unit circle, and you bring down the 3. So that gives you a tangent slope of 3√2. And then I need to take the opposite reciprocal which looks like this. And you do this weird thing called rationalizing to get rid of the square root on the bottom. And when you simplify